varies widely among the various scientific disciplines. For example, chemists, biologists, psychologists, and geologists might all follow a slightly different form of this method. Although this is true, the main parts of the method are uniform throughout all. There are 6 main steps that tend to characterize the scientific method. Step 1. Question. Come up with a question. This is the part where a scientist, you, proposes a question that you want to solve or find the answer to. You can't find the answer until you know the question after all. What is the scientific question that you are trying to answer? Step 2. Hypothesis. This is the step when you make an educated guess, or hypothesis, formed as a statement that you think to be the answer to the question that you asked in step 1. Most of the time, a hypothesis is written as, if I do this, then this will happen. For example, if gummy bears are placed in water for 24 hours, then they will swell to over twice their original size. Step 3. Experiment/procedure. This is the portion in which you follow a detailed step-by-step description on how to do your experiment. It's like following a recipe when baking. It is intended to either prove or disprove the hypothesis you made in step 2. Step 4. Observations/data collection. The results of the experiment are usually in the form of a statement that explains or interprets the data. Observations can be made through the senses and/or scientific equipment. Step 5. Analysis. This is the part when you compare the results of the experiment to the prediction posed by the hypothesis you made at the beginning. Mr. Smiley asks himself, was my hypothesis correct? Step 6. Conclusion. Now you must sum up your findings based on your observations. This is where you answer your problem or research question. You make a statement of whether your data supported your hypothesis or not. Pretend you are a 5th grader and your teacher, Mrs. Barthley, shares with you that you will be performing an experiment today. She explains that you will be doing the Mentos soda experiment and gives you a list of materials that you will be using and a brief overview of what you will be doing in the experiment. First, you must follow the scientific method that you just learned about in class. Let's take a look at an example. A student, Carly, asks herself, I wonder what effect Mentos will have on soda if you were to put it in the soda bottle. Will it fizz, explode, or change colors? Carly predicts, if you place a roll of Mentos in a soda bottle, then it will begin to bubble and the color of the soda will turn white because a chemical reaction will take place.
Hello students, it's Mrs. Barkley and I'll be showing you the procedural steps of the Mentos soda experiment. First you need a soda bottle, put it on the ground, unscrew the lid, and then you're going to place the Mentos in the soda bottle.
During step 4, Carly observes that when Mrs. Barthley placed the Mentos in the soda bottle, an explosion happened. She saw that a lot of bubbles formed and that the soda came spurting out of the bottle like a fountain. During step 5, the analysis section, Carly concluded that her hypothesis was only partially correct. She did see bubbles, which she predicted, but the color of the soda did not change.
So Carly, what did you conclude from this experiment?
Wow, with the help of my teacher, Mrs. Barkley, I understand that when chemicals of different substances combine, there's several observations to make to identify our chemical reaction, including bubbles, change of color, and temperature.
So now that we have taken a look at the scientific method, why is it important? The scientific method is the cornerstone to modern science. Without a formal method of determining questions and their answers, we wouldn't have science or the knowledge we have today.